Okay, I'm going to jump to 3.1, which is the section your teacher's most likely to jump to, even though I'm skipping 2. 2 is very important, but 3 is all about quadratic functions. And what are quadratic functions? They're the same as parabolas. That's what I talked about earlier, which is a shape like this. And you get a shape like this when you essentially multiply what are two binary, or well, let's call them two lines together. So if I expand that, this here, I get x squared. By the way, this is called the factored form the way it is. If I expand it, I get x squared plus x minus 6. Don't forget the x squared. And the sure sign that you're dealing with a quadratic is when the largest exponent in it is a square. So you have to look at the exponents over each x if there's any other x's. And you should always add like terms. So here, after I've expanded, is known as the standard form. Sometimes there's a number there. That's why they put an A, a B, and a C. And these numbers in standard form will later feed into the quadratic function. So know all these forms quite well. This form, which also can have a number in front of it, is known as a factored form. And it's known as a factored form. By the way, the only information you get from a standard form is the y-intercept. Because when x is 0, those will disappear. And all you're left with 0, comma minus 6, the y-intercept. The only other use of the standard form is there's some information we're going to learn. You can actually discover the vertex by taking minus 2b, which is usually the number in front, and divide it by a, which is usually the number in front here. And that would be the x value of the vertex. But that's a trick we're going to learn later on. It's not part of this covering. This is called the factored form because if I were to graph this, it will go through the points, not minus 2, but 2, comma 0, 2, comma 0. And it'll also go through the points negative 3, comma 0. And you'll also discover that the axis of symmetry is halfway between those points. So the distance between those points is 5, which means 2.5 this way, which is negative 0.5. So the axis of symmetry will be at x is equal to negative 0.5, which also happens to be the x value of the vertex. So the axis of symmetry and the vertex share the same value. So I could now plug that into the formula to determine the y value and thus the vertex. The other important information about the standard formula and this formula and the other formula coming up, if there's a negative here, the parabola or the quadratic function is facing downwards. If it's positive, it's facing upwards. So just recognizing what numbers in front of the x squared, positive or negative, or in front of the factored form, positive or negative, or in front of the next form coming up called the vertex form. All right, well, the vertex form is achieved by completing the square. And in this case, it would be this. And 0.25 minus 0.25. And I believe it will be this. 0.25, like that. And I believe that'll be the vertex of this. I'm not 100% certain, but we're going to get to completing the square. It's a very important skill. But this is called the vertex format. And in it, I can see the x value of the vertex and the y value, which tells me this vertex is actually down here, which makes sense because it's got to be facing upwards with this positive number in front, which is just really just a 1 at this moment. So that means the vertex is here at negative 0.5. Notice the x is always the opposite of what you expect. And then the actual y, which is negative 7.25. The vertex format is great for spotting the vertex and for solving various questions about when you're trying to figure out some x values. Because solving for x in this format is very difficult, as in this format. But for this format, when there's just one x, because there's two x's up here, just one x makes solving for x very easy. This, interestingly enough, is how we come up with the quadratic function when we don't use any actual values for a, b, or c, and we just end up with a, b, and c up here. And in the quadratic function, which we're not doing this chapter, you're going to learn that this part is very important. When this part comes out to positive, there are 2 points where the parabola crosses the x-axis. When it comes out to 0, it's crosses the x-axis at one point, so the vertex is on it. And when it comes out as negative, it doesn't cross the x-axis at all. So you have a parabola that's below the x-axis or above it. So solving the discriminant is something important later on, but we're going to get to that. These are the three main things we need to know. So this chapter is going to deal primarily with reviewing how to fill in a function. So when I see f of 1 here, I put it wherever I see x, and f of 1 is going to be the y, whatever. So here, 1 squared times minus 3 is minus 3, plus 4 times 1, 4, so we're at plus 1, minus 1, 0. So f of 1 is equal to 0. In other words, when x is 1, y is 0. That's what this means. So you got to get used to function notation. And notice that you can even put in letters. So all I do is everywhere I see, I put a bracket around the x's, and everywhere I see it, I either replace it with k here or minus k, which is going to be useful later on. Then here, they just want you to expand it, learn how to expand it. And here they want you to identify the vertex, and by the way, the vertex will dictate the range, but I want you to be aware that all parabolas, all quadratic functions have a domain of xer. That never changes. And the axis of symmetry is also going to be the x value of the vertex. So I can see here, the x value of the vertex is minus 3, so the axis of symmetry is x is equal to minus 3. I can see here the x value of the vertex is 5, so the axis of symmetry is going to be x is equal to 5, a vertical line. And it's called the axis of symmetry because the axis of symmetry acts like a mirror that each side of the parabola will match on either side of the axis of symmetry. The actual vertex over here is 5, 1, and the actual vertex over here is minus 3, minus 4. The range is dictated by the y value, so in this case, y is smaller or equal to minus 4 is the range of this, and in this case, y is bigger or equal to 1. State the vertex axis of symmetry. So when you don't see a number like this, but you do see x squared and no other x's, treat the x value of the vertex like 0, and the y value is plus 4. So the axis of symmetry is also going to be x is equal to 0. So the vertex is 0, 4, and the axis of symmetry is x is equal to 0. And it's opening up because it's a positive number in front of the x squared. Over here, this is in vertex format. So the minus 7 is the x value, and minus 3 is the y value. So minus 7, minus 3 is the vertex. And the axis of symmetry is x is equal to minus 7. It is opening downwards because that's a negative, which means that minus 3 is the highest y value that will exist. This is also in vertex format. The vertex is 4, 1. It's opening upwards, and the axis of symmetry is also x is equal to 4, plus 4, not minus 4. This one's harder to see, but it goes through the points minus 2, 0, and 5, 0. That's because if I put a 5 in here, this becomes 0, and the whole thing becomes 0. Minus 2 in here, this becomes 0, and the whole thing becomes 0. We'll get more on that. But as a result, the axis of symmetry is halfway between plus 5 and minus 2. And that happens to be a 7 distance, so it's 3.5. If I add them together and divide them by 2, minus 5 plus, or plus 5 plus minus 2, 3, divided by 2, 1.5. So you can add them together and divide by 2 and find the exact coordinate. So x is equal to 1.5 is the axis of symmetry. When I plug in 1.5 into this formula, I get 3.5 times negative 3.5, which I'm not quite sure of. So it's 3.5 squared, and it's going to be negative because one's negative, one's positive. But then it's going to multiply it by negative 3, so it's going to be positive. So I'm going to get a y value of 36.75, which means the x value of the vertex is 1.5, and the y value is this. And it faces downwards because of this minus. Solve each equation. So this goes back to factoring. The factors here will be minus 8, minus 3. So that means it goes through the it's going to go through the x-axis at plus 8, 0 and 3, 0. This case, you'd have to multiply by 15 and see if you can find out what two numbers multiply to minus 15 and add up to minus 2. So it's all factoring again. So we can do factoring another time. This you have to get them all to one side and have them equal 0 before you solve, and then use your factoring. Now in some cases you're not going to be able to do the factoring, which means you have to find the a, b, c of the standard form and put it into the quadratic function. This is a difference of two squares. It's x plus 9x minus 3, so the x-intercepts are 3, 0, and minus 3, 0. This one is minus 6, no, minus 9 plus, that's a tough one. It's not minus 9 plus 2. It's not minus 6 plus 3. It's not coming to me right away. 6 and 3, no. That one might require the quadratic function. And these others I'm not going to do. But this is in the wrong order. I can factor an x out of a minus 2x out of both of them. So this one here. So if I rearrange it properly, it's this plus this. And then when I factor minus 2 out of it, minus 2x, I get x minus 3, which means it goes through 0, 0, and 3, 0, because this just means 0, 0. So those are the y-intercepts. The others you all have to factor. Graph, sketch a graph. So that's going to be 0, 3. So I can just take 0, 3. It's going to face upwards. And then I can just find easy points on either side of 0. So minus 1 will be, so at 0, 3, minus 1 will be 4. And at positive 1 will also be 4. So I would have that. And this will be at the x-axis. So you just do that. You just find some common numbers after you find the vertex. You can also say, well, I know the standard parabola is 0, 0. So I just add 3 to all the y values. And since the standard one has these as 3 points, I can add 3 to all these. So it becomes 0, 3, 1, 4, minus 1, 4, which are the points I found anyway. So this one's goes through the points 2, 0 and minus 8, 0, and it faces down. And if I add those two together, minus 8 plus 2, I get minus 6 divided by 2. Minus 3 is the axis of symmetry. I could plug that in. I get 5 times 5 times minus 5. And you get minus 25 plus 25. So it's minus 3, plus 25 is the vertex. And you can just draw lines through the x-intercepts in the vertex. And then this one here is going through the point 0, minus 4. And then I just multiply all the y values by 2 and subtract 4 of the 3 standard points. And this one here has a vertex of minus 2, 3. It's facing downwards. So to all the y values, I multiply by minus 1 and add 3. And all the x values subtract 2. And I'll have 2 other points. This I'm going to skip. Now, they want you to see how these things are increasing. So it's clear that I'm adding 6 here. They're just doing length and then perimeter. But the area here is 2, 6, and then it's clear that this area is 18. So it's going up. Calculate the difference. Okay, so this is important actually. So this is a very important thing to be able to learn. And it has to do with first differences. So let's focus solely on the area. So this is 18. So when I find the first differences, which is the difference between that and that, which are the y values, these are the x values. So it goes 2, 2. Oh yeah, those aren't the x values. This is the x values. So it goes 1, 2, 2, 3, 3, 18. Sort of. I might have to work on that. But anyway, my first differences here show it's 6. And then over here I can see 10. And then you're probably going to see, because it looks like we're increasing the width and the length, we're increasing the length by 2 each time. So this one's going to be 4. And this one's going to be 8. So that means the area is going to be 32. So I'm going to discover the difference of that one is 24. I think, let's make sure. This is going up by 4, and this is going up by 2, it looks like. Oh, no. Yeah, the length is increasing by 2. So this is next one's 8, 16, 32. And the difference, oh, it's 14, rather, 14. Is that right? 20, yeah, 14. So I can see that there's the first differences, but I can see the second differences are 4 over and over again. When you find the first differences are all the same, you're dealing with a line. When you find the second differences are all the same, you're dealing with a quadratic. When you find the third differences are all the same, you're dealing with a cubic. And when you find the fourth differences are all the same, you're dealing with a power 4. When you see the same numbers, however, appearing over and over again, you're actually dealing with a growth curve, but more on that later. This is a very useful skill because once you discover it, you can also figure out the formula. Because now I know this is an x squared, right? Now it helps if I can determine what the x values are, so I'll just call them 1, 2, 3. So that means I'll make up my x values like this. 1, 2, 2, 8, 3, 18, 4, 32. I'll just do it like that. I'll base my width as the x. And I've discovered it's an x squared. So I can write the basic formula in standard form is equal to 0. And it would really help if I had a 0x up here, because if you had a 0x, like 0, 0, you would know c is 0, because when x is 0, that's the y-intercept, and that's always the y-intercept. But we don't. And we know this is the general formula. We don't know a, b, or c. However, we do know x. And when x is 1, 1 squared is 1, plus 1 times b plus c, we know that y is 2. If I look at that carefully, I have this nice equation. So that's one equation and 3 unknowns, so I need 2 more equations. However, when x is 2, 2 squared is 4. 2 times b is 2b plus c, and we know the y is 8. That's 2 equations and 2 unknowns. And now I have a third equation when x is 3. I know 3 squared is 9, plus 3 times b plus c is equal to 18. I have another equation too there, but I don't really need to know it. All I need to know is that I can rephrase this as c is equal to 2 minus a minus b. And then down here on this next equation, I can then, this is a very useful skill, replace wherever I see c, which is there, and since it's plus, I don't have to worry about it, I can replace it with this. Now let's resolve that. 4a minus 1a, 2b minus b, and we'll send the 2 over here. So suddenly I get 3a plus b is equal to 8. Let's find an equation that b is equal to. Well, we know now that b is going to be equal to 8. Oh yeah, and that's 8 minus 2, because I got to bring the 2 over. So it's 6, which means b is equal to 6 minus 3a. We're now going to go to the next equation, and if b is equal to 6 minus 3a, that means my new equation for c, which was this, can be rewritten as well. And wherever I see b, I can replace it in brackets with that. And now the reason that's important is because this minus affects them both. So now I have a c that's all a's and a b that's all a's, which means down here, everywhere I see b, I can replace it in brackets with this. And it's got to be brackets because that 3 is going to multiply it. And that c that I see right there, I can replace it with this. Oh, by the way, I can resolve this a bit. 2 minus 6 and the 3 a's, this is a little bit easier written as this. Like that. So that means I can replace c with that. This is an incredibly useful skill you should learn. And also that it's all equal to 18. When I expand this one over here, so I get 9a plus 18 minus 9a, just by coincidence, plus 2a minus 4. When I add the numbers here, I get that. When I get rid of all the a's, The a's I'm left with are here. These cancel out. When I put the 14 to the other side, I get 2a is equal to 4, which means a is equal to 2. If a is equal to 2, and that's the thing you should write down somewhere, a is equal to 2. If a is equal to 2 and I put it into this equation, and I had a simpler version of it right here, and that's why you want to keep a copy of all your equations. But if a is equal to 2, then c is 0, because 2 times 2 is 4, minus 4 is 0, so c is 0. And b is also 0. So I get the very simple equation that y is equal to 2x squared. To test this out, what is y when x is 1? 1 squared times 2 is 2. What is y when x is 2? 2 times 4 is 8. What is y when x is 3? 3 squared 9 times 2 is 18. So it matches what's going on over here. This is an incredibly useful skill. I kind of jumped. But we're going to look at properties of quadratic. So here's the properties. There's always a vertex. And there's not always, there's either 2 x-intercepts, 1 x-intercept, or no x-intercept. But the number of x-intercepts possible happens to match the power over the x. So if I have this, I can immediately identify it as a quadratic because it's got a square here. That means this can have 0, 1, or 2 maximum x-intercepts. This is a slight jump in topic, but it's important to notice. If I have this, it doesn't matter what the numbers are. And it's got cubed here, squared here, and just x there. This one can have, this one must have 1, which we'll deal with later, 2, or 3 max, so that we can see x-intercepts, so that we can see that the maximum number of x-intercepts happens to relate to the power. We're also going to learn that odd power, and it's always, you got to always look at the highest exponent. We're going to also learn that odd powers must cross once, but even powers don't ever have to cross, but their maximum is still their power. So that means something to the x to the 4, which is an even power, can cross 0, 1, 2, 3, or 4 x-intercepts. So that's an important thing to notice. Also, it faces down if the leading coefficient is negative and faces up when it's positive. So right away when I'm looking at this, I can tell you it's negative. I can also tell you the vertex is 5, 18. So as we get in more into the vertex formula, we can also try to figure this out. So since I can clearly see the vertex, I'm going to write it as, okay, well, vertex formula is y is equal to sum a, x minus the x value of the vertex. It's plus 5, so it's minus 5. And the y value is 18, so it's just plus 18. The only thing I don't know is that a value. However, I can clearly see, I can put in any other point. I can clearly see 2, 0 as one of the x-axis. So for y, I can replace it like this. For x, I can replace it like that. Squared, don't forget it's squared. So we get this, 0 is equal to 2. Oh yeah, sorry, not 2. A, I don't replace the a with 2. I replace the x with 2. That's, so minus 3 squared, don't forget it's squared. So I get 0 is equal to 9a, because it was squared, I just didn't write it. So 9a is equal to minus 18, which means a is equal to minus 2. Now that I've discovered that, I can rewrite it like this. Don't forget the squared. That's vertex format. So I knew the format. All I need was one other point other than the vertex to figure out the a value. But I can also do it with factored format. So I can, this is the factored format, also has some a in front of it. Now I forget the letters. I think it's h and k. But I can clearly see from there that there's a minus, it's going to be minus 2 and minus 8. The opposite of what is in there. I just don't know the a value. Now I can substitute any point other than an x-intercept, so I can even use the vertex here. You usually want to use the easiest point, so I could use any point they show me, but I'm going to use the vertex. So I can see at the vertex y is 18. I don't know a, but I do know x is 5. So I get this. And 5 minus 8. So I get this. You're going to discover the same answer, by the way. Minus 3. Minus 3. 18 is equal to minus 9a. Therefore, a is equal to minus 2. So now I can go back and put this minus 2 right there. And now I have the formula of the vertex. Notice that it's still minus 2. And that's one way to do it. Now, you can't really come up with a standard format without expanding these. I mean, you could find the y-intercept, but then you'd need 2 points to solve it for the other ones. And they don't even show us the y. Do they show us the y-intercept? Oh, they do. But it's pretty, there's a fraction in there. It's much more consistent to use pure points. Here's the first differences we were talking about. So when I take this number, it's always the second number minus the first. Minus 14 minus 32 is plus 18. 0 minus 14 is plus 14. In other words, this number is going up by 18. This number is going up by 14. This number is clearly going up by 10, then 6, then 2, and then it looks like a turnaround point. So first differences are not all the same, so we're not dealing with a line. But when I look at 18 to 14, it's going down by 4. 14 by 10, it's going down by 4. 10 going by 6 is going down by 4. So that means it's got a negative 4 second difference. Now there's another rule here. Once you find the number of second difference, you can actually find the... There's an interesting trick. I'm going to have to look it up. But you can actually find the leading coefficient from that. But I'm going to have to look it up. It's a very useful trick too. But now that I can see the second differences are all the same, I know instantly I'm dealing with a quadratic or a parabola. And then you can see that they put it in, they've kind of spotted the vertex because right here it hits a peak and then goes down. Do they have a graph? Yeah, so they're using this graph. So they did exactly what I did right there. And then they did it again with the x-intercepts instead, exactly as I did. So that's the big lesson here, and then you'd be able to solve things. So there's a expanded, and right away you can see the y-intercept is 0, 25. That's the y-intercept. But we can't answer this one unless we know the vertex. We can't answer this unless we know the x-axis. We can't know this until we know the vertex. Although there's a trick. It's minus 2 times b, so minus 40, divided by, or is it minus b divided by 2a? It's minus b divided by 2a. So it's minus 20 divided by minus 10, which is 2. So the vertex x2, and then 2 squared is 4, so that's minus 20 plus 40, so that's 45. So it's going to be 2 comma 45. Let's see if it is. Let's see if they tell me the vertex. There, yeah, there's the 45, and there's the axis of symmetry, 2 comma 45. But let's answer the questions. How high off the ground? Well, the first question, how high off the ground is the window? So he throws it out the window, so at times 0. So we would plug in 0 for here. We get 0, 0, and we get the y-intercept. So we get that. And we can expect it, by the way, because this is a negative quadratic facing downwards. We can expect it with the negative number to go here. So if he's throwing it out the window, it's unlikely it's going straight down because it looks like he's tossing it to a partner across the street. So he's going to throw it up. And he happens to throw it up, and we only start measuring this quadratic right here at time 0, because usually for these things, the x-axis is going to be time. So that means it starts right here at 0, 25, which is useful. That's how high the window is. If his partner misses the tool, when will it hit the ground? Right there. Well, that's when y is equal to 0, which means you would have to solve this as a by factoring, right? So we'll go down like that, do this, and we'll move this up actually like that. There we go. And we'll just move this up, and we'll actually put this one down here instead. So be careful. The simplest thing here to do first is factor out a -5. Make your life easier. You never want your leading thing to be a negative number anyway when you're factoring. So it's going to be minus 4t. That's a t squared, so I shouldn't put t2. And then a minus 5 here. Makes your factoring a lot easier, doesn't it? Because right away I can see that the factors of minus 5 are minus 5 and plus 1. And you might say, well, that's odd, because that means the x-intercepts are negative 1, comma 0, and 5, comma 0. And right there you could say, well, negative time, that's weird, and you're right. We're pretty much ignoring that. We just now know that he's throwing it this way, and it's going to hit the ground at 5 seconds. It's going to have a height of 0 at 5 seconds. Now, that could also allow us to say, well, if minus 1 is here, if I add these two numbers, plus 5 plus minus 1, that's 4, divide by 2, 2, I've found the axis of symmetry. So the axis of symmetry is going to be at x is equal to 2. It's always halfway between the x-intercepts. Now that I know 2, I can plug that into my formula, which we've already discovered. If I plug it in, I put 2 here, I get minus 3 times positive 3, it's minus 9. Minus 9 times minus 5, so we discover a vertex is 2, comma 45. But the good trick is minus b divided by 2a. So minus 20 divided by, what's 2 times minus 5? Minus 10, 2. That will give you the x value of the vertex. So now we've discovered, we've answered this. We've answered this. If the path of the tool's height were graphed, where would the axis of symmetry be? We just did that. Determine the domain. Domain of all parabolas xer, except we're dealing with a real-life situation that starts at time 0. So that means the domain technically does not have negative time, and it's in t's here. So t is bigger, equal to 0, even though in reality it's xer for all parabolas. This has a real-life limitation. We don't go back in time. And the range, since it's facing down, and we're dealing with h instead of y, h is smaller or equal to 45. That's the maximum height it can reach. But guess what? It also doesn't pass through the ground to reach China. So we would write it like this, which means 0 is the lowest point of h, and 45 is the largest. H is always between or equal to those points because it does hit the ground. So it's interesting that this parabola, which would normally have less limitations, has real-life limitations. And that's the trick, is you got to make sure you're talking within the question. Let's see if they actually do that for the domain. So yeah, they do indeed put a real-life restriction. And they actually put a real-life restriction there, because it can't go through the ground to China. So the vertex here is 1, comma minus 5. The axis of symmetry is going to be the same as the vertex, so x is equal to 1. The direction of opening, this is positive, so it's up. The y-intercept is when x is 0, so we can figure that out. Minus 1 squared is 1, times 2, 2. Minus 5 is minus 3, so it's 0, comma minus 3. The domain is going to be xer, but the range, because this is an upward-facing parabola, is going to be y is bigger or equal to minus 5. So there's the vertex, there's the axis of symmetry. It's opening up. We discover, indeed, there's the y-intercept. And we discover xer, and indeed the range is y is bigger or equal to minus 5. These are all useful tools, but I would say first, second differences, and let me go back and look and get back to you later about what's incredibly important about this. And so that's my intro. I'm going to stop that and do the questions next.